Excuse me, sir. It
And
sounds like it looks like it's perfect from where the screen is actually perfect.
oh, you're not having a problem today now, huh?
Not having a problem. Everything's perfectly clear. Everything's running smooth.
All right. So all they did when I worked with Comcast was they reset my modem. But
Oh,
I checked with my class yesterday, and they said it was mostly clear for them too. So that might have really helped.
oh, good.
I'll ask for feedback before we take off today, so that everybody can let me know if it's been better today. Um, and we're gonna jump right into things. We'll go for half an hour from 12:30 to 1. We'll take a 15-minute break, and at 1:15 the exam opens up, and you can start doing that until 2:15. All right, so
Okay.
um, practice quiz problems. Just two. What would the directions be for each of the problems below? If there were directions in front of the problem, what would the words be? Let me give you a little bit of time. Okay, 15 seconds more. All right, so for the first one, the directions would be simplify. If you got rid of the parentheses, then you'd have some like terms you could put together, and you could make it look more simple. Mean the same thing, but it would be more simple. The directions on the second one would be to find the x that makes this true, and that's solve. Only since last class did we start doing solve. Prior to that, it's been all simplify the entire course, learning how to simplify different things. And in math, it can things can blur together. And this is a really important distinction to keep mentally so they don't blur together. Notice when you're working with simplifying, and when you're simplifying, what's allowed to happen is you can have multiple equal signs. And you can stretch them out like this. See, two equal signs in the same line. In same, let me make that a little more legible. And same line is okay. But on this one, we don't. And then we divide by 5. One equal sign per line. Only one. You can't stretch out multiple equal signs. You're balancing this out, and you're getting to. So we treat these very, very different. So we have to have different categories in our brains for these. When we're simplifying versus when we're solving. All right, and that's it for the practice quiz today. And we're going to jump right into, since we only got a short amount of time today, right into this section 2.2 multiplication property. It's solving more equations but using this property of multiplication. And I'll explain what that property of multiplication is in context. So number one, it says state the following with words. I'll do the first one. So if you are interested in all in math history, first, when algebra first came about, when they first started using letters in equations, and then you had to solve these equations that had a letter in them, it was all done with words. They hadn't developed how to work with symbols yet. And the words would have been something like this. What is the number? Type it in a little faster. What is the number that when you divide it by 4, you get 3? So, the x is just some unknown number. And it's kind of interesting too, is why do we tend to use the letter x? Why not A, B, C, and so on? When they were first making algebra books, that was back when they had to actually do a typesetting, and they had to physically take this letter that would stamp onto. And they tended to, X's don't get used a whole lot in normal usage, so they had a bunch of X's left over. So they said, all right, we can use any letter we want, let's use X as the letter for the number that we're trying to find. All right, so for the next ones, let me have you do the next two. Write this out in words in a similar way, and replace X with, some unknown like I did. All right, let me give you a quick little bit of time. And what I want you to do when you write this out is type it into your group chat. So just put B and then type it up. Hold on to it for a minute though, before you hit enter. Okay, you can go ahead and hit enter, and then also do C. And hit enter. And just kind of examine what other people got. And let me, so what number, I'm going to use pound sign for what number, subtract, or maybe what is the number that when you subtract 3, you get 10, something like this. And then last number, the last one, what number times 4? Now I'm reversing the order here because it makes it go a little quicker. What number times 4 is 20? Kind of like it was x times 20, or x times 4 instead of 4x. But you get the same result when you multiply in either order. All right, now When you write these out with words, the answer kind of jumps out at you. Let's go back to the first one. What's the number when you divide by 4? You get 3. Oh, it's 12. What's the number when you subtract 3? You get 10. It's 13. And so the original algebraists that would write these out would write out the sentence and then would write out the answer. What number times 4 is 20? Well, it's got to be 5. All right. Now we get kind of, many of you might have an automatic response of, hey, there's a solution process that I have to go through. I have to, add 3 to both sides on part B and so on. But once in a while we'll tend to make mistakes when we just follow a process. So if we also have other layers and other ways that we can look at it, it'll be very helpful. So let's just practice this a couple more times. Type these D and E into your group chat as well. And state the answer for each of these as well. Use that way of thinking that comes naturally when you write it out in words to then just state the answer. Okay, and let me give about 20 seconds more, and then I'm going to type up my answers. Alright, what number divided by 7 is 3? And 1/2 of what number is 8? Now notice I used the word of. I could also said 1/2 times what number. But it turns out that multiplying, when you have fractions, is the same as the word of. Multiplying and of will often just swap each other out. Okay. Alright, and let's look back. The answer on on D was, it's 21, because that divided by 7 is 3. And half of 16 is 8. All right. What we're going to do next is we're going to come back with these and use the solution process on each one of these. And on A, we have x divided by 4 is equal to 3. Now the solution process is this. What we're trying to do is isolate x. Now to get x all by itself, I have to get rid of this 4. How is the 4 attached to the x? By division. What will detach it is what we call in math the inverse operation. It's kind of like the opposite. So what's the opposite of dividing by 4? And that is multiplying by 4. So we would take this equation, x over 4, I'm going to leave a little space, equals 3. And what I'm going to do is I'm going to multiply both sides by 4. And this has to do with the title, which is the multiplication property. You can multiply both sides of an equation by whatever you want. Now when I multiply by 4, that's fine on the right, but on the left it might be nicer to make that 4 4 over 1. 4 over 1 is the same as 4, you just don't have to write the over 1. But when you're combining it with other fractions, it's kind of nice to see it in this fraction form. Alright, then I'm going to reduce. Now, why these two things will reduce, divide bottom by 4 and top by 4. Why they reduce is this. Take any number you want. Take 3. Multiply it by 4, you get 12. Divide by 4, you get back to 3. You always get back to that same number. If you multiply by 4, making it 4 times as big, divide by 4, you're shrinking it by a factor of 4. You always get back to the number you started with. Whether that number x was 3 or 10 or what, doesn't matter. So these two kill each other off. That's trying to make it grow, that's trying to make it shrink by the same amount. And so what we're left with then is x equals 12. Now that's the answer that we knew we were going to get. As you're looking at it, but we're getting used to this process. And now, here's the tricky thing about math. The really successful math people don't just replace the ability to put it into words with symbols, but they keep both skills at their ready, and then whenever they need it, they can go back to this one. And then say, all right, does this make sense? And often they'll check their work that way. What number divided by 4 is 3? Oh, that's 12. That makes sense. And so they'll use the solution process, and then they'll come back to the worded expression and kind of say, does that make sense? And they're back and forth using both things quite a bit. So this one, the solution process is, well, we already knew this solution process. And when you come back to here, 13 is a number that when you subtract 3, you get 10. It checks. We go to this next one. The solution process. Let me write out the problem again. 4x equals 20. We're trying to isolate x. So I have to get rid of, to get x all by itself, I have to get rid of this 4. How is it being attached? By multiplication. The inverse of multiplication is division. So I divide by 4. Common student mistake, and it happens sometimes accidentally, but fairly frequently, is divide by x. And the thing is to keep the goal in mind. Trying to get x by itself, we get rid of everything else around the x. Okay. The 4's will cancel out. You just get x is equal to 5, which is what we knew had to be true. And then x, you do these last two, d and e. Use the solution process for both of these. And we give you about 15 seconds more. They're a little bit, it takes a little bit to get used to when they have these fractions. Alright, so this first one, x divided by 7 equals 3. The objective is to isolate x. So I have to get rid of the 7 on the same side of the x. But it's being divided, so what do I have to do is I have to multiply. If I do it on one side, I do it on the other side. Now, the 7 doesn't need to be over 1 here, but it's handy to put it over 1 here. Alright, so these things will cancel out, and I'll come up with x equals 21. And that makes sense when we look at this in words. What number divided by 7 is 3? 21 divided by 7 is 3. Half of what number is 8? All right, we have to get rid of the 1/2. Again, we're trying to isolate the x. Now, if I divide both sides, since 1/2 is multiplied by the x, I could divide both sides by 1/2. But when I divide 8 divided by 1/2, that'll take quite a while to do. You have to do a copy dot flip again and so on. There's a shortcut with this. The shortcut is when you're trying to get rid of a fraction that's being multiplied, you multiply by what's called the reciprocal. Now 2 over 1 is the same as 2. And let me put the words here. We multiply by the reciprocal of 1/2. Now the reciprocal means you flip it over. And why would I multiply by the reciprocal? Because it gives this one and this one on top, one on the bottom, gives them a chance to cancel each other out. Divide by 2 and I get 1, divide by 2 I get 1. And so the new answer, the new line is, remember, one equation per line, so we don't stretch out another equal sign here. All this becomes 1 times x, which is just x, and 8 times 2 is 16. And that agrees with our intuition. 1/2 of what number is 8? 1/2 of 16 is 8. All right, and we are getting close to being out of time, so here is some other ones to practice. And I'm going to go kind of quick on these, and in fact, I'm going to skip down to C. Yeah, let's start with C. They're a little bit different type. Let me give you a minute to work on C on your own. And when you get an answer on C, type it into your group chat, and I'm going to call on a group after this. Okay, 20 seconds more. Let me ask group 2, what did you come up with on this one?
Hello, this is Amalia. 50?
50? Okay. And how did you do it? What was your process? Amalia?
We didn't write it down.
Okay. Were you kind of using kind of like this worded kind of thing? Like what number divided by 5 is 10? Was that possible?
I did, but I don't know.
Okay. All right. Now, that can work. So let's look at it. If we think of it that way, what number, when I divide it by 5, is going to be 10, is 50, but there's a problem here, this negative sign. This negative sign is not going to allow these two sides to match. So, in that case, I say, let's try sticking an extra negative here. Make it negative 50. So then, negative 50 divided by 5 would be negative 10. And then this negative out in front would make 2 negatives, which would get us back to positive. So that would be correct if we had negative 50. Now, let me show you another way to look at this. This problem is the same as this. Fractions, if I had the fraction 1/4, these are equal to each other. If I have one negative, these are equal to each other. Doesn't matter whether the top one's negative, the bottom one's negative, or the number up in front is negative. Alright? So if I have negative m over 5, you don't distribute it to the top and bottom. You put it with one or the other. Now I can say, oh, I want to get m by itself. So what am I going to do to both sides? I am going to get rid of the negative 5. If I'm going to get rid of the negative 5, I'm going to multiply both sides, because it's divided, by negative 5. Alright, so then my new result will be the negative 5's cancel out. I get m equals negative 50, which is what we were coming up with before. Alright, and one last one. I'm going to jump down to e since we're running out of time. I usually put more than I can actually do here. Alright, let me write the problem again. Negative 3/5 x equals 9/5. What I'm going to do is I'm going to put parentheses around that. And I'm going to multiply both sides by, remember, I could get rid of this negative 3/5 by dividing both sides by negative 3/5. But the shortcut is you multiply by the reciprocal. And two negatives would make a positive. So the reciprocal of a negative, you still keep its sign. You flip the bottom one up to the top, top number to the bottom. Okay, now I multiplied this side by negative 3/5, my negative 5/3, so I multiply this side by negative 5/3. Okay, now I'm going to get two negatives positive and 15 over 15, which reduces down to 1, or whenever you multiply a number by its reciprocal, everything cancels out and you just get 1. 1 times x is x. And on this right-hand side, divide by 5, divide by 3, and notice that there's one negative sign. So the whole answer is going to be negative. 3 times 1 over 1 is 3. And that would be it right here. Alright, so the homework is 1.2. I mean 2.2.
Was the answer to that last one 3 or negative 3? Sorry.
The last one was negative 3. Because we multiplied both sides by negative, and then this right-hand side became negative.
Okay, thank you.
Okay, glad you asked for clarification. Alright, so give me a little feedback. If everybody could give me a tiny bit of feedback, that would be helpful. On the quality of the connection. Was it a good connection? Or was it your screen still stopping today? Oh, better, better. Perfect. Nice. All right, so maybe resetting the modem did fix the problem. I did go fast today because of the short half hour that we had. All right, and all right, it was also brought to my attention that because my son gets online and he has problems sometimes at this time, and he doesn't have the same problems in the morning and in the evening. So sometimes I think there's just too many people online all at once, maybe across Santa Fe, all students in school and so on. And so we may still run into some a little bit, but it sounds like it's doing a lot better. All right, so the exam. Let me take you, when you go into Canvas, your screen will look like this. Hit modules. And then at the end, so module 0, there's class videos, and module 0 is getting started. Module 1, at the bottom of module 1, this is where you did the practice test, and here is test chapter 1. And it's just now become available at 1 p.m. So, and actually no, it doesn't become available until 1:15 p.m. So you've got a little bit of break time, and then from 1:15 to 2:15 the exam is available. So download it, and then write all over it, and then upload some kind of image to it. To me, before 1:15. And if something happens, because I know we are, most of all of us, working at home. You know, if you have kids and they just need attention, and there's just, you know, an interruption that could not be avoided, it's not a problem. You just email me, explain what happened, and then you can, you know, if it's past the turn-in time at 2:15, just email the exam to me and explain what your situation was, and that'll be fine. All right. Any questions about the exam? Yes.
Is it a... You go ahead first.
Oh, okay,
Go
Freddie.
ahead.
This is Kylie. So are we like scanning it in like we do our homework for the
Yes.
test?
Yep. And there'll be a link right in this spot to submit it back, just like there's a homework link. Yeah.
Oh, okay, cool.
Okay, so it's very much like doing the homework.
Okay, and is it a PDF document, or
It's
is it
a
a...
PDF document, yes.
Okay.
Yeah.
Okay, I know what to do then. I'll write within the PDF.
Okay.
Yeah.
You can, you could write within it if you have the ability to do that, or you could just take pictures, or, you know, if you had a printer and so on as well. Okay.
All right.
You need to stay on Discord.
All right.
Oh, and one more
yes.
thing. There was a student by the name of Jamie. I can't pronounce her last name. Crox. That's her last name, and she said that she had a quick emergency appointment, so she could not do the test. I think.
Okay, then she
Yeah.
can send me an email, and I'll work something out with her.
Okay, I don't think she did. She just put it in the general discussion there.
Okay, well, thanks for letting me know. I'll expect something from her. Okay.
You're welcome.
And anything else? I will, so class really is ending now. I'll check in on Discord to see, if you have any difficulties, something strange is happening, you know, You can send me an email or you can type something into Discord. I'll check in periodically with Discord and with my email. All right. We will stop here. I'm going to turn off the video.